What's up, guys? So I have here my Project 3 code made for analyzing the execution time of three separate uh, sorting algorithms using the boost.chrono library. Um, it was pretty straightforward. These are so the three sorting functions that we're looking at are quick sort, merge sort, and heap sort, and we have the bulk of this functionality defined in the .h and the .cpp file named sorting algos. And in the main CPP, we just call the functions on three 10,000 data point data sets. And we also use a random number generator to fill the vectors randomly, and we pass the function, or I'm sorry, we pass the random numbers to the three arrays, the same set of 10,000 randomly generated numbers. So it's a fair trial, of course, on all three functions. So I repeated the execution of this many times to take data points of the standard deviation, the mean, other statistical metrics, and to compare that between the three algorithms. That's included in the report, but heap sort, to my surprise, was actually far and away the most consistent and the fastest by a very significant margin. I have been working on setting up a program that can run itself 10,000 times and store the information on its own instead of having to manually run the code X amount of times. I think that was a bit much for the scope of this project and something I'm hoping to do later on. But just in case anybody that ends up looking at the code, that's what these other files are. I have an array generator .cpp and .h file that uses random generation functions and just data allocation functions to generate a specified amount of arrays of a specified size. So it's quite flexible, but I also had the experiment function that I did not complete, but this was my attempt to create this program that could run itself a given amount of times and then just store the data itself. But yeah, if anybody's wondering, that's what the experiment and the array generator files are. And I was hoping to implement all of that functionality in the main .cpp, but it was a bit of a mouthful. So yeah, if you see, it's pretty simple. I just run the code, and here are the values in microseconds of the execution times of the three algorithms. And you'll see, of course, that if I run this many times, the numbers it's pretty easy to see a trend in the numbers. Merge sort being substantially the lengthiest, the most time-consuming algorithm of the three, and heap sort and quick sort being quite good and sometimes one better than the other. I guess it's worth mentioning also that quick sort is in some sense the most reliable in terms of performance in the long run, I think, after passing like a 10 million size array. But it does approach a big O score of n to the second power pretty quickly if the data is actually has quite few random numbers, and it behaves in a way that it can't find a good pivot point to start the algorithm when there are so many similar numbers and then just a few that are sporadic. But yeah, so here's a few more trials, and as you can see, the trend is pretty apparent. And yeah, that is about it. Well, thank you so much, guys. Thank you to whoever is watching this and grading this, and thank you, Professor Alazazi, for a great semester. And I wish everybody a good summer, and I hope you got something out of this code, and maybe can use the code in the Boost library to do something cool yourself. All right, peace.